So at present we have more than 20 students, 22 participants are there in this meeting. So our expert has already joined. So now we are going to start the session. So very good morning to all of you. So this is the third day of this FDP on flow characteristics and turbulence statistics in alluvial channels. And this is the third day. And in the first session, we have an expert talk on flow behavior in a scour around Aspartyx by Dr. Ajay Singh Lodhi, sir. So I welcome you, sir.
Thank you.
So I am the brief introduction. So Dr. Ajay Lodhi has presently working as an assistant professor in soil and water engineering at College of Agriculture Balaghat, Jabalpur, MP since 2015, and sir has done his BTech from agriculture engineering in 2003 from KNKVV, Jabalpur, MP, and MTech in soil and water engineering in 2009 from Punjab Agriculture University, Ludhiana, and his PhD from in hydraulic engineering in 2015 from IIT Roorkee. So sir has qualified ICAR JRF in 2007 and ICAR NET in 2013 and 14. And the PhD topic was scour around spur dikes and bridge piers founded in cohesive sediment mixtures. Sir has published more than 12 research papers in a very reputed journals. So now I am inviting Dr. Ajay Singh sir for the session.
Thank you so much, sir.
Yes.
Firstly, I am very thankful to Professor Dr. R.K. Jain, course coordinator, and Professor Sudhanshu Dikshit and Professor Utkarsh Nigam, course coordinator, for giving me such wonderful opportunity to present here at Atal Portal. The topic given me flow behavior around Aspartyx, flow behavior and scour around Aspartyx. Myself, Dr. Ajay Singh Lodhi, I am working as associate professor in Department of Soil Water Engineering at College of Agriculture, Balaghat. In this topic, first we have discussed some introductory part about Aspartyx, and I have used Bractino plus instrument for measuring three-dimensional velocity around Aspartyx in scar hole. So we have discussed some technical part about Bractino plus instrument. Then I have presented a study, some results of my PhD objective. So come to the Aspartyx. So what is Aspartyx? We can say Aspartyx is an elongated structure or a hydraulic structure that is one end on the river bank or end of the bank of the channel, and another end is projected into the stream or current. Aspartyx is used for the protecting the stream bank from the erosion. It is also used to create a stable pool in unstable or disturbed stream. This picture I have taken in 2014 from river Vakra near Haldwani, Uttarakhand. This is an example of practical application of Aspartyx in river Vakra. First picture shows the installation of Aspartyx at the river bank, and it also shows the scour at the tip of the Aspartyx. But second picture shows the failure of Aspartyx due to over scouring. Now come to the types of Aspartyx. There are many types of Aspartyx according to permeability, according to submergence, according to infiltration, and some special type of Aspartyx also used. According to permeability, there are two types of Aspartyx. First, impermeable Aspartyx, and second, permeable Aspartyx. Impermeable Aspartyx installed at the end of the river, first bank of the river bank. It can be built of local soil, stones, gravel, rocks, or gabions, and used to divert the flow away from the bank. But permeable Aspartyx can be made from timber, bamboo, steel, or reinforced concrete piles, and allows water to pass through it at reduced velocity. Similarly, according to submergence, there are two types of Aspartyx: submerged Aspartyx and non-submerged Aspartyx. When water flows over the Aspartyx, means Aspartyx is fully submerged in the water, is known as submerged Aspartyx. But when Aspartyx are not fully submerged in water, or where water passes through any length of Aspartyx, are known as non-submerged Aspartyx. According to inclination, there are three types of Aspartyx: attracting, deflecting, and repelling Aspartyx. And attracting Aspartyx points downward and attract the flow towards its head and thus to the bank. But deflecting Aspartyx is simple perpendicular to the flow and divert the flow away from the bank. But in repelling Aspartyx, inclines in upstream direction and divert the flow away from itself, so that during the flood, the flow is diverted toward the middle of the river. And according to its appearance, means shape of head of the Aspartyx, there are some types of Aspartyx, straight Aspartyx. This is also example of deflecting. Mole head Aspartyx, L's head, T head, and hockey stick. Now we discuss typical flow around Aspartyx. Flow past the Aspartyx is divided into the three zones: main flow zone, mixing zone, and wake flow zone. Wake flow zone is also divided into return flow zone and reattachment zone. A main flow zone from the head of the Aspartyx to the opposite side of the channel. In the main flow zone, the velocity is accelerated, that is near about 1.5 times of approaching flow velocity. Mixing zone, it is between main flow zone and wake zone. Returning flow zone is subdivided into there are many small and large eddies is developed within the wake flow zone, and in the reattachment zone, water is reattached after the separation into the downstream of the channel. Similarly, typical flow field, we have to discuss typical flow field in a scour hole. Suppose there is a Aspartyx at the bank of the river, some water coming from upstream to downstream, and this strikes on the Aspartyx. There are some bow wave formed, and after the strike, water goes downward and strikes on the riverbed. So due to the stagnation of the water, stagnation pressure of the water, their horseshoe vertex is developed in the upstream of the Aspartyx, and wave vertex developed in the wake zone of the Aspartyx. Upstream part, in upstream part, horseshoe vertex developed, and in wake zone part, behind the Aspartyx, wave vertex developed. Due to the development of such vertices, there is a formation of scour around the Aspartyx. Then some turbulence characteristics of the flow we will discuss in this presentation. What are the characteristics we have find out, how to interpret it for the analysis purpose. So in the earlier slide, we have know that there are around the Aspartyx, there are three-dimensional flow, that is turbulent flow. The development of scour around Aspartyx is due to these type of three-dimensional flow. Water goes some longitudinal direction, transverse direction, and vertical direction. So these complex phenomena, the scour is formed, and they are poorly understood and difficult to characterize. So the major turbulence characteristics are mean velocities in longitudinal, transverse, and vertical direction. We have denoted as U, V, and W. Reynolds stresses and turbulent stresses. These are some instruments used for the measurement of three-dimensional flow velocity. First, acoustic Doppler velocimetry, ADV, we have known as ADV. It is designed to record instantaneous velocity components at a single point with high frequency. ADV is capable to record near about 200 frequency up to 200 megahertz. I have used a Vectrino Plus instrument that is capable to record velocity at 200 hertz. The measurements are performed by measuring the velocity of particle in remote sampling volume based upon the Doppler shift effect. Second instrument is particle tracking velocimetry, PTV. PTV is a velocimetry method or a technique to measure velocity and trajectories of moving objects in fluid mechanics. These objects are naturally buoyant particles that are suspended in fluid flow. Another instrument is particle image velocimetry, PIV, that measures the velocity of fluid as it passes the observation point that is fixed in a space. So in this presentation, we have we have to know in detail about ADV, Vectrino Plus instrument. First instrument is Sontag Argonaut ADV, and second is Vectrino Plus Micro ADV that I have used. Vectrino Micro ADV, Vectrino Plus Micro ADV, that is 16 megahertz Vectrino Plus Micro ADV. This instrument measures the velocity From that transmitted transducer at 5 centimeter below the transducer. Okay. The volume of the near about I think 9 mm. Feature of the 16 megahertz micro ADV. This is 3-axis velocity measurement sensor mounted on 25 centimeter stem. Its high sampling rate up to 50 hertz. Small sampling volume less than 0.1 cubic centimeter. Large velocity range 1 mm per second to 2.5 meter per second. Excellent low flow performance. No recalibration needed. Comprehensive software including horizon ADV, proven Sontag reliability. So this is the window of Vectino Plus software. First tab is file, then communication, then data collection, then filter, view, upgrade, and help. In communication, there are 3-point serial port, terminal, emulator, and connect. Serial port are already filled, that is a default setting. And after the click on connect, we have checked the our connections are properly fixed. If connections are properly fixed, then ADV is connected. So it is show status as okay. Then in the data collection, there is some other tabs, the edit configuration, load from instrument, start data collection, start distance check, start probe check, stop. I am audible?
Yes, sir. Yes, sir. Completely audible.
Okay, thank you. And slides is also seen. Visible?
Yes, completely visible.
Okay, okay. Thank you. So under the data collection tab, there is add a configuration, load from instrument, start data collection, start distance check, start probe check, stop data collection, start data recording. There are some tab under the edit configuration. There we have set sampling rate. How much sampling rate we have decided to in the experiment, and we have taken our reading at 25 hertz. Then other setting as default is default the transmit length 1.8, sampling volume 7.0. That is default setting. We have only select here sampling rate 25. I have selected 25. Here is maximum range is 200. And under the data recording, left hand side, right hand side, data recording. So there are maximum. I have selected here 1800 sample. I have taken each point at near about 1800 samples at a point. And there are you have decided to how much seconds you want to take reading at a point, how much minute or hour or samples. You have fill here the value and create new file or stop recording. I have selected stop recording. After the completion of 1800 sample, recording was stopped. Then I have changed the depth and then again started. So after the click on OK, there are this is the view of the recording data, velocity, standard deviation, amplitude, SNR, SNR nearly more than 14, I think, for the good observation, and correlation percentage is greater than 70. Then here sample number and time, sample number, temperature, distance in centimeter. Here, how you have taken for the experiment, at what distance you want to take the reading. This is distance in centimeter. Then status is okay. This is all about. And in this this one shows the bacteria plus a downward blue arrow. This is for directly. You want to, if you will click on this, then start the run. Then if you want to check, if you want to set the distance, you have to click on this center one, bacteria plus sign and downward blue arrow and near surface. So you will check the distance, how much above or down you have to set your probe. Then upward and red arrow, with red arrow, this is for stop the run. So now we have to discuss some my experiment on flow behavior around Aspartyx found in cohesive sediment mixtures. So this figure shows the star pattern around Aspartyx and non-cohesive and cohesive sediment. In the first diagram, we have to see here in first picture in the scar around Aspartyx and non-cohesive sediment, the maximum depth of scar was formed at the upstream of the Aspartyx and maximum depth was obtained at the junction of wall and Aspartyx. But in case of cohesive sediment, maximum depth of scar was formed at the downstream of the Aspartyx, and it was the maximum depth at the downstream of the at the tip of the Aspartyx, where the tip of the Aspartyx, there maximum depth of scar was formed. So this study presents the result of flow and turbulence characteristics measured by downlooking 16 MHz bacteria plus micro AdV around partially submerged Aspartyx founded in clay gravel mixture. Velocity and turbulence data was collected at various cross-section at wake and upstream of the Aspartyx, within and outside of the scar hole. The longitudinal velocity and turbulence intensity and stresses were measured and its quantitative analysis was carried out. So some brief review on literature about ADV. Author Sokolov in 2004, he done a case study on turbulent flow and sediment distribution in ground field. He used ADV at a sampling rate of 25 Hz for 100 to 300 seconds. And he also used Explore B 1.5 software developed by Nortec for the processing of measured instantaneous velocities. Similarly, Conhele 2008, a measured and simulated flow near submerged dike. He also used ADV, but frequency was 15 Hertz for 5-minute duration. Duan 2009 mean flow and turbulence around experimental Aspartyx. He used micro ADB at sampling rate of 25 Hertz. He measured about 1500 instantaneous velocity at each node. Then Gaussian and Vagafi experimental study on scour and flow field in scour hole around T-save Aspartyx in 90-degree band. He used ADB Bactino at a sampling rate of 50 Hertz for a period of 1 to 3 minutes. Then Egger 2009 mean flow and turbulence around 2 series of experimental dike. He used 16 MHz Sontag Bactino ADB at a sampling of 25 Hertz, and he used WinADB software from Nortec was used to post processing of data. Then in Cochrane 2011, he used ADB at 25 MHz for 30 seconds, and stable effect of grind layout on the flow in grind field laboratory experiment. He used PTV, particle tracking velocimetry. So this is the author works on ADB and how much time they used for a particular, how much time they record the data at a particular node, at what the frequency this slide shows. Then my experimental setup and procedure. The extensive experimental work for the present study is carried out in the Hardlick Engineering Laboratory of Civil Engineering Department, IIT Roorkee. I have used clay, sand, and gravel. This is a photograph view of sediment used in the experiment. This is the median size of clay is 0.0014 mm, sand 0.24 mm, and gravel 2.7 mm was used in the experiment. Then other properties of clay was liquid limit 43%, plastic limit 22%, plasticity index 21%, OMC 19%, maximum dry density 1.675 gram per cubic centimeter, and specific gravity is about 2.60. And I also performed the X-ray diffraction test for the identifications of minerals present in the soil sample. So the composition of different clay minerals were found to be kaolinite, elite, and montmorillonite. The uses of sediment mixture were also determined for the different compositions. Then 3 types of Aspartyx I have used in the experiment: 6.1 centimeter, 8.9 centimeter, 2 centimeter transverse length. Then 10 types of sediment mixture I have used. These all mixtures taken by weight: 10% clay and 90% gravel, 20% clay, a mixture of clay and gravel, and mixture of clay, sand, and gravel. Sand and gravel taken in equal proportion, and clay was varied from 10 to 50%. Then flow characteristics were carried out around 11.52 centimeters per die on 30% clay and 7% gravel sediment mixtures bed. And this is the photographic view of flume established in the Hardlick Engineering Department, IIT Roorkee. So the total length of the flume was 25 meter, and width was 1 meter, depth was 0.3 meter, and slope of the flume was 0.003. And the working section of the where Aspartyx was installed, having length was 4 meter, width 1 meter, depth 0.6 meter, and the bed thickness was 0.3 meter. Means depth of the flume, and normal depth of the flume was 0.3, and then the working section beyond this 30 centimeter deep, total 0.6 meter. Then flow velocity and discharge measurement. Flow velocity was measured by a pitot tube 1 meter before the Aspartyx. and sharp custard weir, which is installed at the end of the flume, was used for the discharge measurement. This is the procedure for the bed preparation, mixing of sediment and compaction. First, equally weighted means 10% clay and 90% gravel, or any proportion which may be. We have taken equally weighted clays and gravel mixture and mix it thoroughly. Then add water into the mixture and left for 24 hours. Due to this, the moisture content is homogenized within the all mixture. After the preparation of the mixture, first we installed the Aspartyx in the groove provided in the flume. Then we have filled mixture. Each mixture is 10 centimeter depth, and near the Aspartyx, then a roller was used to compact the bed, and near the Aspartyx it is compacted by hand hammer. This is the steps followed for the preparation of experimental zone. After the preparation of sediment mixture, the test section was filled with prepared mixture after installation of Aspartyx at predetermined location in the groove of the test section. The test section was started at 12 meter downstream of the flume entrance, and the Aspartyx with transfer length of 11.52 centimeter was installed at 14 meter downstream to the flume entrance. The filled sediment mixture was compacted in 3 layers having 10 centimeter thickness approximately by dynamic compaction method. It was achieved with the help of cylindrical roller. The area near the sides of the channel and Aspartyx was compacted using wooden hand hammer having dimension of 40 centimeter length, 10 centimeter width, and 7 centimeter thickness to provide bend between the layer. Each layer was near 10 centimeter. After the filling of 10 centimeter, each layer was roughened before the placing another layer over it to provide the strength between the layers. A sharpish towel was used to remove the additional sediment from the bed surface, and it was leveled with a wooden template from beginning to end of the test section. Then sediment mixture was filled into the test section up to the general flume level, and its final thickness in the test section was kept up to 30 centimeter. After the preparation of experimental run was start to observe temporal variation of Aspartyx. The depth of approaching flow was measured at 1 meter before the Aspartyx. Once the equilibrium condition was achieved, the flow was stopped and bed was allowed for sufficient time to drain out the water. The dried scar wall was fixed by spraying the resin, instant adhesive over it, and left for drying. Now our setup is ready for 3D velocity experiment. Again, flow was started in the flume very slowly up to predetermined level. After the stabilization of flow depth in the flume, the 3D velocity run was started. A downlooking 16 MHz bacterium plus micro ADV manufactured by Normalize was used to measure instantaneous velocity in 3-dimensional direction x y at a sampling rate of 25 Hz. This is a setup for bacterium plus micro ADV probe of the ADV was fixed in the ruler bar of pointer gauge, and this is the estimate plot of the measuring grade. Total 56 point was taken. 56 node was taken at where the three-dimensional velocity was measured at different locations. Up to the 2 centimeter, the below velocity measurement were taken at various cross sections at 68 locations, as shown in schematic plot of measuring grade figure. The origin 000 also shown in the figure. At each measuring node, 1800 instantaneous three-dimensional velocity was recorded. The lowest point of measurement was 5 mm above the channel bed, up to 2 centimeter from the bed. The measurement was made at 5 mm interval, while the interval was kept 1 centimeter in higher resolution. Up to 2 centimeter measurement taken 5 mm interval. The data was collected from ADV, had a file extension .vno. Using the Vectino Plus software, the VNO file was converted into .adv file that were readable by WinADV software, and then WinADV software was used for the post-processing of captured data. So under the data collection, there's data conversion tab. Here we have add the file .vno with .vno extension and then add file. Then we have to click on the blue arrow that is converted file into .adv extension. For the conversion, we have to add file. Then in data conversion, there is some setting. We have to select NDV. When we have select NDV, then file is converted into .adv extension. Here we have selected 0_16_1.vno extension. Then we have a click on NDV. Then we have click on the blue arrow. Then file is converted at 0_16_1.adv. Then after the conversion of raw data was filtered using WinADV software by phase space threshold typing method given by Goring and Nikora in 2002, and communication error was filtered out. The measured velocity in proposed data file was used to calculate the following turbulence characteristics: mean velocity, Reynolds stresses, and turbulent intensities. So this is the WinADV software window where data was filtered out. First, we select the data and through file add ADV data. Then process filter data. We have to check on compute, summary, statistics. Then we have to fill out some average SNR or minimum SNR value. I think we have selected here 14, and we have also checked the phase space threshold, this typing method, and also check filter error. Then we have to click on OK. Then statistics file is saved in the defined location. Then the discussion of results and discussion. So steam velocity and longitudinal direction of flow field was measured from the Aspartyx at -5 in the upstream 5 centimeter, 10 centimeter, 15 and 40 centimeter, and in at the downstream of the Aspartyx at 5, 10, 15, 20, 40, and 80 centimeter. Total 68 nodes were decided for the velocity measurement. The Aspartyx was installed at 0 location, and the negative and positive signs represent the upstream and downstream side of the Aspartyx. In the transfer direction, the both upstream and downstream velocity was measured at by equal to 5, 10, 20, 25, 35, and 50 near about up to the center of the flume. Total width of the flume was 1 meter. So we have taken a velocity measurement up to center of the flume from the right hand bank to center of the flume at 5, 10, 15, 20, 25, 35, and 50 centimeter. So this diagram shows the normalized velocity profile
Dr.
of steam
Ajay,
velocity in Aspartyx.
yes, Dr. Ajay, sorry to interrupt you. Hello.
जी सर.
मैं ये बोल रहा था, you can ask some
जी सर.
participants if they have any doubt up till now, so it could be clarified if they have. You can ask if.
Okay, sir.
Right, so that would be better. So that whatever is covered, at least if they have doubt, they can clear it.
Okay, sir. So if anyone have doubt up to this, please.
Dear participants, if you have any doubt, then you can ask. You can write in chat box. Okay.
Okay.
Okay, sir, you can continue now. If anybody is having any question, then he may ask. No issue.
So here Z value shows the negative Z value shows the scar hole depth, and positive Z value shows the above the surface depth of the water above the surface. H is the approaching flow and depth. Here small u is the longitudinal velocity and u0 is the approaching flow velocity. So in this diagram, we have seen at and y equal to 15, y equal to 15, it means y equal to 15 means the flow velocity just front of Aspartyx at from the left hand side bank 15 centimeter means just 11.252 centimeters our Aspartyx, 3.5 centimeter away from the tip of the Aspartyx. There is the maximum velocity was achieved at the front of the Aspartyx, near it is near about 1.2 to 1.46 times of approaching flow velocity. At 20 centimeter it was a little less, and 25 centimeter it is also less. But in the just front of the Aspartyx, it was the max velocity was. It is near about 1.2 to 1.45 times of the approaching flow velocity. But you have seen in the scour hole, that is the some points are below the zero, near about 6-7 points were carried out. The velocity is high at the scour hole. Then if we have to see at the just the front of the Aspartyx at a y equal to 15. So this is the velocity profile of the velocity profile, at x equal to 0 value, x equal to 5, 10, 20, 80, and -5, -15, and 40. So in this figure, we have also see the maximum velocity was the x equal to 5 and x equal to 10 point, matlab positive. Just behind the Aspartyx, the maximum velocity was achieved at the 15 centimeter transverse length. Then the variation of normalized longitudinal turbulence intensity, square root of average of u prime u prime across the flow depth in various planes. Shown in the figure, the turbulence intensity was normalized by shear velocity u star in the approaching flow, and the z was normalized by approaching flow depth as earlier, z by h, and turbulent intensity. Longitudinal turbulent intensity, square root of u prime is normalized by approaching shear velocity. So we also see here the turbulent and longitudinal turbulent intensity was near about 5 to 9 times of approaching flow shear velocity. So this is and also the reason for the scar hole formation. Then the normalized profile for turbulent intensity component W prime W prime. So we have also see here it is near about 3.25 to 3.75 times of approaching flow velocity. Then come to the Reynolds stresses, the normalized profile of Reynolds stresses, U prime, W prime component that is normalized by square of the approaching flow shear velocity, and Z is also normalized by H approaching flow velocity. So we have to see here also the Reynolds stresses that is near about 2 to 6 times, 2 to 5 times of approaching flow velocity. Then Reynolds stresses component of V prime W prime, it is does not show any significant contribution in the scour, information of scour. Then the turbulent kinetic energy, that is the half of U prime bar plus V prime bar plus W prime bar and TKE, turbulent kinetic energy, that is also 20 to 25 to 45 times of the approaching flow shear velocity. So that this is also contribute the formation of scour hole. Then the coordinate analysis was also carried out for the to know the contribution of bursting events in the formation of scour. To carry the coordinate analysis, the longitudinal fluctuation as the U minus UR, and the vertical fluctuation velocity W prime, that is W minus WR, was decomposed using their sign by WinADV software developed by Nortec in 2000. The data filtration was carried out by phase fill threshold method included in the WinADV software, and these filter data was used in further analysis. A code was developed in Fortran 90 to obtain the contribution of outward ejection, ejection, and inward interaction, shape events of the whole data for the particular Z by H value. That is, I think, about this code, Dr. Janser is also described earlier in his presentation. This approach was proposed by Liu and Bilmarth in 1973 and is termed as U prime V prime quadrant splitting scheme. In present study, the quadrant technique have been used to identify bursting events in the flow within the scarred profile around the Aspartyx. The interaction between the turbulent burst and sediment motion can be determined by coordinate analysis as by Kava et al. 2005, Storm and Papanicolaou 2007. So turbulent was divided in the 4 quadrants at outward interaction, in which U prime is greater than 0 and W prime is greater than 0 is and that is in quadrant 1 ejection. Quadrant 2, in this the U prime is less than 0 and W prime is greater than 0. Then in inward interaction, quadrant 3, U prime is less than 0, W prime is less than 0, and then sweep falls in quadrant 4, U prime is greater than 0 and W prime is less than 0. So this is the distribution of quadrant based on the U prime and W prime. In the simple meaning, it is possible to spot an ejection event if low velocity fluid U prime is less than 0 and upward velocity W prime is greater than 0 observed to occur simultaneously. Similarly, sweep events can be identified simultaneously observing a high velocity fluid moving toward the bed U prime greater than 0 and W prime less than 0. It means W prime has the downward direction. 2 other events are defined as outward interaction when W prime greater than 0 and W prime greater than 0, and inward interaction U prime less than 0 and W prime less than 0. These 2 events are generally observed to be less dominant in flow field compared to ejection and sweep. And this is the definition sketch of the U prime W prime of quadrant, all 4 quadrant given by Neju and Nakagawa in 1993. Here, the center of the these quadrants present the whole. And this is the bursting events around partially submerged dike. In the first figure shows the at the x equal to -5 means just upstream of the Aspartyx. Here in this diagram we have seen ejection and sweep events participate more than outward and inward interaction. Second diagram shows this is the distribution of velocity after the Aspartyx at downstream of the Aspartyx from 5 centimeter from the Aspartyx. In this figure we have seen overall outward and in ejection and sweep events participate more, but within the scour hole in my case, generally in all cases ejection and sweep participate more, but in this case because these experiments were taken in the cohesive sediment mixture, scour hole was very small. So outward and inward interaction participate more. It is near about 25 to 30 or 40%, and outward and ejection and sweep participate near about 16 to 24%. So this is some findings. A very less value of velocity component U negative were obtained at location 5, 5, 5, 10, 10, 5, and 10, 10 behind the Aspartyx, where larger value of U are obtained when we move from y equal to 15 to y equal to 25 at 5 to 20 centimeter x values. At the point x equal to 5 and y equal to 15, the U was value of U varied from 1.24 to 1.48 times of approaching flow velocity at just front of the Aspartyx. The analysis of flow characteristics revealed that the turbulence intensity, Reynolds stresses, and TKE were larger at the wake of the Aspartyx. Then coordinate analysis of ADV data shows the value of upward and inward interaction were higher within the scour hole in partially submerged dike as compared to the value of ejection and sweep events. While the out of the scour hole, the value of ejection and sweep event were higher as compared to the value of outward and inward ejection events. This is all about my presentation. Thank you so much. So if anyone have any doubt, please you ask.
So dear participants, now it's open for question and answer session. So if you have any questions, then you can ask.
Sir, can you share this paper, please?
Hello.
Yes, sir. Hello. Sir, can you please
Yes,
share
yes.
the details of this paper?
Paper. Yeah, I will share
Yes, sir.
in chat box.
No, sir, you
Yes, sir.
no
That
issue.
would
You can
be.
mail to us and then we will share with all the participants. No issue.
Yeah.
Yes, Neerav ji.
Okay, I will share this paper
No, sir.
to
That
Dr.
would be great,
Rajan.
sir.
He will share. He is also author of this paper.
Yes, sir.
Yes.
Oh, sir. Okay. Okay. Yes, sir. Thank you, sir.
Yes, any question?
Sudhanshu, there is one question in chat box.
Hello, sir.
You can read it
Hello,
out.
sir.
Yes, please.
Lodi, sir. Hello.
Yes, yes,
जी
you
जी
are audible.
बोले.
Sir, can you conclude anything about silting phenomena in this study?
Which silting phenomenon? Hello.
Please repeat the question.
Yes, sir. Sir, can you explain the means deposition of the sediments or the silting phenomena just before the spur or after the spur? Can we conclude, sir?
Yeah, Dr. Ajay, he wants to say that whatever deposition takes place behind the spur dike while scouring process goes on. So can you show some picture having that deposition?
Just a minute, sir.
Yeah.
In case of non-cohesive sediment, there is deposition in the behind of the spur dike, but in case of non-cohesive sediment, there is no deposition or very less deposition just behind the spur dike. So
you can demonstrate which one is cohesive one and which one is non-cohesive, so that participant will get clear idea. First figure, this one is.
First figure shows the non-cohesive sediment, scour around the non-cohesive sediment.
Yes.
Cohesionless sediment, yes. And second and third picture shows the scour in a cohesive sediment.
So Lakshman, to answer your query, the first picture is belonging to sand and gravel mixture, which was mixed in some proportion, and spur dike was placed and scour took place. And you can see the deposition on the downstream side of the spur dike. Wherein third second photograph is of clay sand gravel or clay gravel mixture, where clay is mixed in various proportion. You can see very less deposition on the downstream of the this one spur dike, wherein the third or middle photograph you can see clay has been washed out, and whatever gravel and sand mixture is there, that you can see deposited even in the scour hole and little bit on the outside of the scour hole. I hope this will solve your query, or still to the questionnaire. Yes.
Yes, sir.
Is it okay or anything?
Sir, partially,
Yes.
sir, partially solved the query because I was asking about his test section.
Which section?
Sir, the test section or the spur he has taken in the test section.
Okay, test section. Can you, Dr. Raja, do you have full photograph showing spur dike and channel hole? Can you show that photograph?
1 minute, sir.
He's asking for flume photograph.
Yeah, whole flume showing
Whole
Yeah.
flume cross section photograph.
spur dike as well as the test section.
This one.
Whole flume showing. Yeah, this one. Yes. So just can you enlarge it so that we can see where is spur dike? This is there. Yes.
Yeah, this one Aspartyx.
Yeah. So the Lakshman, now you can raise your query. What exactly you want now? Yes, please.
So the deposition of the sediment in this particular test section.
Okay, so what happens? See, this is the solid apron in the initial portion, and the test section is of around 6 meter length. But deposition or whatever erosion will take place, that is near the spur dike. So deposition will always on the downstream side of, either in case of pier scour or in case of spur dike scour, deposition will take place on downstream. So no deposition before this is spur dike. This projected portion you can see on the left hand side. So before spur dike, there will not be any deposition. That is always either on the rear of the pier, rear side, or we can say the wake side of the spur dike, or wake side of the pier, or in some case you do have in side of the pier also. Is it all right, Lakshman?
Okay, sir. Okay.
So, Sudhanshu, there is one question written in chat box.
Yes.
You can read it out.
So one question is there, can I normalize the turbulent intensity with inlet velocity, approaching velocity? Yes. Normalize the turbulent intensity with the inlet velocity.
So Indulekha is asking, can I normalize the turbulent intensity with inlet
That
velocity?
actually we are doing in the formula itself. U dash वाला जो है ना turbulent in the formula of turbulent intensity we are dividing it by U bar. That I think ma'am is asking. Formula of turbulent intensity.
Dr. Indulekha, are you there?
Yes, sir.
Yeah.
Is it the usual practice to normalize with the shear velocity, or can I normalize it with the approaching flow velocity?
Since this turbulence intensity or turbulence characteristics, it is very near to the shear stress and shear characteristics. So it is general practice that we normalize all this Reynolds stress or turbulence intensity using shear velocity. Otherwise, that is the non-dimensional parameter. It is not 100% necessary. Even you can normalize it with either average velocity of the flow or inlet velocity, what you have written. The idea is to make it non-dimensional. And why we do that dimensionless, so as to make it applicable to the field condition. Idea behind normalization is that you can apply those results to the field condition, because we are doing experiment in channel, and those data we are directly applying to the field wherein flow is much larger than the which we encounter in our channel. So that is the basic thing behind it. Is it okay, Indulekha?
Okay, so if anybody else is having any question, then he or she can ask.
Any query raised from anyone? Any doubt regarding Aspartyx or Samnan is there? Our PG students are also there. They can look into their dissertation topic.
Excuse me, sir.
Yes, Roshan. Yes, boliye.
Yes.
Sir, as earlier, sir has discussed, there is partially submerged Aspartyx. So, is there gets any deposition, sir,
Dr. Ajay?
in partially submerged cases? Hello, sir. Am I audible?
Yes, yes.
Yes,
audible.
you are audible. I think sir, Ajay sir is
Dr.
muted.
Ajay, can you hear me?
Actually, sir, mic is muted.
Wait.
Yes, yes. Now it is audible.
Yes,
In
Dr. Ajay?
case of partially submerged dike or submerged dike, there is deposition in the just behind of the at the wake of the Aspartyx in non-cohesive sediment.
Okay.
Do we have pictures
is
on both cases, for both cases, partially submerged and submerged?
Yeah, both
At the
cases.
end of run, can you show that those pictures?
At this time.
If you have at the moment.
So at the moment, I don't have actually.
Okay, fine.
I require.
Okay, any other query?
okay. Thank you, sir.
Yeah. Nabil? Even Neerav is also there. Neerav?
Yes, sir.
Yeah. Do you
Yes,
have
hello,
any
sir.
query to ask?
Yeah. Sir, actually, is there any article available to comparative study of lab experiment and field view?
Yes, please speak loudly.
I just asking about, sir, if any article I will read for. I want to read.
Yes, yes. Lot many articles are available for both Sontech and Nortech. We have PDFs. So, we can
Okay,
also
okay.
share. Yes. Lab manual.
Even on YouTube, there are some videos are also available.
Videos are also there. Yes.
Okay, okay. Just, sir, I just asking about comparative study of lab experiment and field experiment. Okay.
There is no comparative study, but they have shown the application part in some papers. It means
Yes, yes.
one paper is there. Yes, yes, it is there.
Okay, sir. Okay.
One paper is from, I think, University of Queensland is there.
Excuse me, sir.
Yes.
Yes, yes.
Sir, which experiment has shown us in the presentation? So, sir, please, can we share that presentation to us, sir?
Yes, yes, we are trying to get the PDF copy of these presentations. So afterwards, after getting our PPTs in PDF form, we will try to share with all the participants through mail, or we can share the drive. No issue.
Particularly that experiment procedure, sir, that was given there.
Yes, yes, yes. Yes, we will try to share because it will help you, and also this lecture is recording, so you can also have a look afterwards also. Yes.
Thank you, sir.
Okay, thank you, sir. Thank you, sir.
Yes, any other question?
Any other question?
બચ્ચુ ભાઈ છે? બચ્ચુ ભાઈ? બચ્ચુ ભાઈ is there? Chitranjan? Chitranjan is there? Today, yes.
नमस्कार जैन साहब।
हाँ नमस्कार डॉक्टर आशीष। आई वाज जस्ट लुकिंग टू योर नेम।
मैंने कहा आज ना इसको मैं हैंड करके देख लेता हूँ, स्टार्ट ऐसा होना कि लास्ट पे प्रॉब्लम हो जाए।
हाँ तो अभी आप ज्वाइन हो पा रहे ना? हाँ नाउ वी कैन सी यू।
नहीं मैंने ज्वाइन कर लिया था 10 o'clock।
अच्छा yes sir, to all participants we can see our next speaker. He was just trialing up whether is there any difficulty in Microsoft Team to join at right time. So he had been there with us in lecture, and just to inform to all participants. बहुत सारी सीट्स दिख रही हैं आपके पीछे इनाम की.
हाँ डॉक्टर साहब, और सब बढ़िया है.
Right. So there is no difficulty as such. To share and to like speak बराबर टीम में ना.
हाँ शेयरिंग तो हो जाएगा, इसमें कोई दिक्कत नहीं.
That's fine.
चलिए ठीक है, ओके.
Yes. So anybody else? Meanwhile, Dr. Ajay is just showing our his paper, in fact, in partial Aspartyx and submerged Aspartyx. So we'll wait for a minute. Probably he will share that two photographs. Just Rushan has.
Okay. Thank you, sir. I wanted to see that photograph, sir.
Yeah. He's just searching. So just wait for a minute, and then we will conclude it. Okay.
I am audible?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
This is some pics for this is deposition behind the Aspartyx in partial submerged Aspartyx. This one.
So just make it enlarge, Dr. Ajay, these photographs.
This one?
थोड़ा
Sir, please maximize, sir.
Yes, whichever you would like to show us. Still, it is in a smaller size, you can see.
Now to see?
No, not yet. We can just see only the what we can say, the thumbnails.
Oh.
All photographs are shown in thumbnails, not in actual size.
1 minute, sir, 1 minute.
Just open that photograph in your PC. And then
Sir, battery is low.
अच्छा एक दो photograph दिखा दीजिए. I think because of the battery probably it is a problem. So to all participants, in fact, he was trying to depict all this photograph, but he is there in Chhattisgarh region where you can have some power cut, and he does not have much battery to keep his PC or laptop on. So at the moment, it will not be possible to depict all those photographs, but I'll insist him to share at least one or two photographs so that we can at least compare the position in case of partially submerged dike as well as fully submerged dike. So Roshan, probably by
It's
today evening we would be able
okay,
to
sir.
show that.
It's okay. Thank you, sir.
So, as a
It's okay. Thank you.
concluding remark, I would like to say that Dr. Ajay Singh Lodhi, he was my PhD student at IIT Roorkee when he was doing his PhD from 2010 to 2014, and all experiments, whatever he has done under my supervision and my late guide, Dr. UC Kothari sir, and with his sincere efforts, he was able to publish a lot of papers on this area where scour around Aspartyx in cohesive sediment mixture like clay gravel mixture and clay sand gravel mixture. So because this power failure actually has logged out, his laptop is not on. So Sudhanshu, can you conclude session? Sudhanshu, are you there?
Yes, sir. Yes,
Yes,
sir.
so you can conclude actually he has logged out
Yes,
because
definitely.
his laptop has been shut down.
Yes, yes. So this was very nice, informative session by our expert, Dr. Ajay Singh Lodhi sir, on the flow behavior score around Aspartyx. So thank you, sir, for delivering the lecture in this FDP and accept our invitation. So because of some power cut, sir is not able to continue, I think.
And one
So
more,
now we are,
Sudhanshu,
yes,
one more information I would like to share just for
yes,
you.
sir.
See, to all participants, AICT has made this school to be peer reviewed by external referee. So the Vice Chancellor of Marwadi University, he is peer reviewing this short-term training program, and we have also sent this link to him so that he can join during these 3 days. That means today, tomorrow, and day after tomorrow at any time, and that has been appointed from AICT. So you should be very careful whenever he joins, and if he wants to interact with coordinators or the participants, you should be ready for that. फिर उस समय ऐसा नहीं होना चाहिए कि आपका नाम बोले और you are not answering. That is to all participants who have not yet answered, like Bachubhai Parmar, Bhab Sir Nalil Kumar, Chitranjan Dalai, and everyone. And this is the harsh statement which I have to make because numbers of time your name has been called and you people are not responding, and that is not good. Mere logging into your device will not approve you as a participant. I make it very clear again. I have to make it now harsh. Those people, if they are listening, they are not listening. If they are not responding to their name whenever it is called, I will take a strict action. I'll write to AICT not to issue the certificate, even though you have 100% attendance or you rather appear in exam and clear it. See, the last thing is with me. You do not take it lightly कि खाली आप ज्वाइन हो जाएंगे और उससे आपको मिल जाएगा. And I do not want to be harsh on you. I am also human being, but if you are joining and your name is called, you have to respond 100%. That is very sure. No excuse in that. Otherwise, you do not join. We do not worry to give you the certificate. It is not necessary. See, 10-15 पार्टिसिपेंट भी होंगे, हम उनको सर्टिफिकेट देके उनको पढ़ा देंगे. That is fine. But you are making me angry while you are not answering, and that is not good. You all are learned person. You all are teachers. You all are good students. Everybody. So you should understand how much efforts we are paying, how much efforts we are putting into it to bring the good lectures to you. But you people are not just making an advantage of this. So be sure this peer review process will start right now onwards from the next lecture, and you make sure that you are present physically in the lecture, not only mere logging into it. That's all.
Okay, so all the participants are instructed to be on time at 1:30 p.m. We have a break now, and I have also shared the PDFs of ADV field hydro manual. So in this manual, you will get all the details of ADV, different geometry down looking, side looking, up looking, and 3D measurements. Everything you will get for different applications. All the details are there. Then there are some principles manual. Then one more is there. This is related to this is also very good paper, stochastic nature of flow turbulence, that I have shared. And this is one de-spiking acoustic Doppler velocimeter data, Goring and Nikora, that algorithm paper. And this is also I have shared yesterday. I think I have shared two of my papers. One is related to characterization of flow turbulence in mobile boundary channel, and one related to stochastic. So if you read these papers, then you will definitely get all the idea how you can perform, how you can prepare your sediments, what are the characteristics, what are the different important parameters like M, DA. You can able to prepare your table for the data. You can have a very nice experimental procedure in that also, how you can analyze the data, what are the important relations that you have to check. This is the normalization of velocity with the depth. Then these are the different fluctuating components that you have already seen. Okay, so you can take advantage of these papers, and if you require any other paper, then also I can able to share you related to ADV. I have more than 400-500 papers with me. So if you are interested and you have any doubt at any time, you can contact to our team. Okay, and experts also.
Sure, sure.
Yes, we are ready to
Thank
help
you,
you
sir.
in this domain, and we want that you can take maximum advantage of this FDP and try and take this opportunity to work in this field and do a lot in this field. Okay, so thank you all.
Thank you, sir. Thank
Yes.
you so much.
Thank you.
Thank you, sir. Thank you, sir.
Yes, thank you.
Thank you, sir.
Time pass,